For centuries, humans perceived the universe as a simple and uncomplicated entity. It was once assumed that planet Earth held the central position in the universe. In times past, it was believed that the sun, stars, and all other celestial bodies revolved around our abode in a flawless and synchronized manner. Our perception of the cosmos was primarily influenced by our innate inclination to position ourselves at the core of all things. As human understanding of the universe progressed, a journey was undertaken that ultimately led to the discovery of our true place in the vast Milky Way galaxy. The tale of this cosmic discovery journey is one of determination, innovative thinking, and scientific breakthroughs. It is indeed a fascinating story. In order to precisely determine our position within the Milky Way, it is crucial to have a comprehensive understanding of the actual composition of our galaxy. As we gaze up at the night sky, we are presented with a faint, luminescent band of stars. This celestial ribbon is a recognizable indicator of our galaxy. The formation resembling that of a band suggests that our habitation is that of a flattened disk rather than a spherical structure. If our galaxy were spherical, a notable increase in the dispersion of stars would be observable, with a uniform distribution throughout the whole sky. Furthermore, the band seems to divide the expanse of the night sky, suggesting that we are within its realm, with no position above or below it. It is still impractical for us to vacate this plane in order to gain a complete perspective of the shape of the Milky Way. To embark on such a journey, one would need to traverse hundreds or even thousands of light years perpendicular to this plane. Consider Voyager 1, the most distant human-made object. Despite having traveled through space for nearly half a century, the distance it has covered is equivalent to only 0.02 light years. This underlines the magnitude of the distance that we would need to travel to fully observe the structure of the Milky Way. Despite the absence of advanced technology for direct observations, the determination of the shape of our galaxy and our position in it remained a pursuit. In the 18th century, a notable stride was taken by William Herschel, who is best known for his discovery of the planet Uranus in 1781. Herschel, the subject of our story, was more than a mere astronomer. He possessed the unique ability to chart the vast expanse of the universe, earning him the title of cosmic cartographer. Herschel relied on his handmade telescope as his primary tool in his investigations. This device enabled him to observe the cosmos at a greater depth than any other person had done before him. He was a daring individual who embarked on a groundbreaking mission that had never been undertaken before, to chart the stars of the Milky Way. In the late 1700s, aided by his sister Caroline, he set out on a magnificent endeavor. With unwavering determination and exactitude, he meticulously divided the expanse of the night sky into roughly 600 zones. Within each of these sections, he painstakingly recorded the location and luminosity of every discernible star. The process he followed entailed observing the night sky through his telescope and recording the positions of the stars on a grid. Through his meticulous counting of stars, he proposed that our galaxy was a structure shaped like a disk. The observations made by him indicated that the solar system we inhabit is situated in close proximity to the center of said structure. Yet the map created by Herschel was not completely precise. Unbeknownst to him, interstellar dust exists and obstructs our view of stars in the central region of the Milky Way. Herschel's map revealed that the central region of the Milky Way was significantly less dense than its actual density. The map created by him, despite its inaccuracies, marked a significant milestone in our comprehension of the Milky Way. The map was significant as it depicted the Milky Way as a disk, offering valuable insights into the arrangement of our galaxy. The narration now shifts to the 20th century as we prepare to introduce the next significant character in our story. The destination is the Harvard College Observatory, where an inquisitive astronomer with a profound interest in the universe is currently observing something remarkable. The discovery she has made is poised to revolutionize the field of astronomy and forever alter its trajectory. In the theater of cosmic discovery, it is often said that every star has a role to play. This statement remains valid not just for the cosmic entities, but also for the innovative intellects who have dedicated themselves to unraveling the enigmas of the cosmos. In the world of astronomy, there are few names as illustrious as Henrietta Swan Leavitt. This American astronomer left an indelible mark on our understanding of the cosmos, shedding light on our place within the vast expanse of the Milky Way. Leavitt's focus of work was directed towards a distinct kind of star that goes by the name of Cepheid variables. The stars possess a unique characteristic: they pulsate at regular intervals, causing their brightness to fluctuate periodically. Leavitt's occupation at the Harvard College Observatory consisted of the task of cataloging these stars. This position ultimately resulted in a groundbreaking discovery. 1,777 variable stars were cataloged by her. In the year 1908, it was observed that there existed a direct correlation between the luminosity of Cepheid stars and their pulsation periods. It was noted that the brighter Cepheids had a slower pulsation rate compared to their fainter counterparts. The relationship that came to be known as Leavitt's law enabled astronomers to determine the distance to Cepheids by measuring their pulsation period. This relationship, though simple, was profound in its implications. The establishment of Cepheids as the standard candles for determining astronomical distances is a significant development in the field. She bestowed upon astronomers a promising method that has the potential to measure distances up to 20 million light-years. One may ponder, how does this aid in comprehending our location within the Milky Way? Now, we must introduce another key player in this story, Edwin Hubble. Prior to the 1920s, it was commonly believed among scientists that the Milky Way galaxy was the only galaxy in the universe. The captured images at that time were believed to be star systems within the Milky Way, including Andromeda and other neighboring galaxies, although we now know better. As a result, most astronomers held the belief that the Milky Way encompassed the entirety of the universe. As the advancement of telescopes progressed, a few individuals began to question the aforementioned theory. An increasing number of vague patches in the sky that didn't resemble typical star formation regions in our galaxy had caught their attention. At that time, a significant challenge was the lack of a precise method to measure the distances between stars. The size and brightness of stars can vary greatly. An approach to guessing their distance was based on their apparent brightness. In the vast expanse of the cosmos, a brilliant and expansive star, though situated at a great distance, may appear to the naked eye as close as a smaller and less radiant star. Here is where the critical work of Henrietta Swan Leavitt comes into play. It had been demonstrated by Leavitt that Cepheid variables could be utilized to ascertain the distances to galaxies that were as far as 20 million light-years away. Edwin Hubble, inspired by this, proceeded to measure the distance to the Andromeda galaxy through the study of a Cepheid variable star within it. The scientific community was shocked by his findings. As he delved deeper into his research, he made a remarkable discovery. Andromeda, a neighboring galaxy, existed at an astonishing distance of about 930,000 light-years away. This vast expanse extended far beyond the known boundaries of the Milky Way. With an estimation that is only a third of the currently accepted value, Hubble confirmed Andromeda's location outside the Milky Way. This discovery has reshaped our understanding of the universe. The revelation that Andromeda is a flattened disk of stars, akin to the Milky Way, prompted a query among astronomers as to our position within our own galaxy. The work of American astronomer Harlow Shapley is relevant here. At first, Shapley believed that all that was visible to us belonged to the Milky Way. However, Edwin Hubble's research proved this notion to be false. In the early 1920s, Shapley realized his mistake and decided to rectify it. He began a meticulous endeavor to classify galaxies and managed to document a total of 1249 in just 6 years. Shapley's work, spanning from 1914 to 1918, proved crucial in the endeavor to ascertain our location in the Milky Way. With the most advanced instrument of his era, the powerful M.T. Wilson Observatory's 60-inch telescope, Shapley directed his research towards globular clusters. In the vast expanse of the universe, there exist clusters of stars that are tightly packed together. These groups can contain hundreds of thousands, or even millions, of stars that are held together by the force of gravity. The result is a spherical shape that is awe-inspiring to behold. Above or below the plane of the galaxy, they are found. In the vast expanse of the universe, there exist ancient objects known as globular clusters, some of which have been in existence for over 10 billion years. It was discovered by Shapley that the globular clusters were arranged in a spherical pattern around the galactic core, particularly in the direction of the Sagittarius constellation. It was a noteworthy observation. If one were situated in close proximity to the center of the Milky Way, a plethora of globular clusters would be visible, dispersed throughout the entirety of the celestial sphere. Most of them, however, are only visible near the galactic center, in the direction of the Sagittarius and Scorpius constellations. It is indicated that our location is not close to the center of the galaxy, as hypothesized by William Herschel. Instead, we are situated toward the outer arm, slightly overshooting the actual distance from the galactic center. His calculations were off. The narrator estimated that they were situated somewhere between 33,000 and 90,000 light-years away. Thanks to modern astronomy, we now know that our solar system is situated near a small, partial arm known as the Orion Arm or Orion Spur. This arm is found between the Sagittarius and Perseus arms and is located roughly 26,000 light-years away from the center of the Milky Way. The user describes the Milky Way as an elegant spiral of starlight spinning in the cosmic abyss, which is our home. The comprehension of the universe's grand design, its immense composition, and our position within it has frequently been obscured by the enormity of the undertaking. Up until this point, as Gaia, the European Space Agency's celestial cartographer, sails across the cosmic sea, it silently transforms our understanding of the Milky Way. In late 2013, Gaia began an ambitious journey to create the most comprehensive and detailed 3D map of our galaxy ever conceived. With a mission to survey around 1 billion stars, which is equivalent to 1% of the stars in our galaxy, Gaia has been diligently mapping out the universe. Through the use of Gaia, astronomers are able to observe the Milky Way in its entirety, examining its structure, dynamics, and evolution. By analyzing the data, the overall structure of the galaxy is revealed, including the distribution of stars, the arrangement of the spiral arms, and the nature of the galactic bulge and halo. This particular perspective aids in the refinement of our comprehension regarding our placement within the Milky Way and the manner in which our galaxy aligns with the wider scope of the nearby universe. In the end, the Gaia mission signifies a noteworthy advancement in the realm of astrometry, the examination of the positions and movements of celestial entities. Although not as widely known as the Hubble Space Telescope or the James Webb Space Telescope, this astronomical tool is quietly transforming our comprehension of the Milky Way, making it a significant breakthrough. The data collected by Gaia is precise and comprehensive, making it a valuable resource for astronomical discoveries that will continue to propel our cosmic journey into the mysteries of the universe for decades to come. In a recent discovery, astronomers have observed a black hole that has abruptly altered its orientation and is now directly facing our direction. For those who may have missed the episode, it is recommended to catch up on the thrilling discovery. Thank you for watching. Don't forget to subscribe and click the bell icon.